capable of giving the proper readings or not. So for that a master ball is used. The master ball is placed at the specified location, normally at the center of the table, and the probe is selected probe is fixed into the stylus is fixed into the probe body, and then the stylus is made to scan the surface of the master ball, and the readings are analyzed to check whether the probes are giving proper readings or not. Whenever we select a new probe, we should find whether the probe is capable of giving correct readings or not. So we should calibrate the touch probe to determine the CMM scanning probing error. A sphere of diameter 25 millimeter with negligible certified form error is scanned along 4 recommended scanning lines. So in this picture you can see this is the master ball, which is used to calibrate the probes selected. So this is the probe that is selected and which is to be calibrated. So the master ball is placed at the specified location on the CMM table, and the probe selected is made to scan the surface of the master ball along the 4 lines. This is line number 1, line number 2, line number 3, and we have line number 4. So the probe selected scans the surface of the master ball along these 4 lines as per ISO 10360-4. The time required T for this test must be specified, as speed has an enormous influence on the results. Many CMM manufacturers do not quote this time unless specifically requested, since they may quote an excellent T value, but it is obtained at a slow scanning speed. Now, how do we calibrate the CMM? Now, a reflector is placed at the probe dwelling. So this is the Z axis of the CMM, and this is the place where the stylus is inserted. So at this place, a reflector is placed, and the inspection program is run. The reflector will move as per the inspection program. So the motion of the reflector is tracked by the laser tracker, and then what should be the movement of the reflector as per the inspection program, and what is the actual movement as inspected by the laser tracker. They are compared to check whether there is any error in the CMM movement. So like this, CMM can be calibrated using the laser tracker. Now we can also calibrate coordinate measuring machines by using slip gauges. That means this is the table of CMM on which slip gauge of known length, say a length is equal to 10 millimeter. So a slip gauge of known length is placed, and then we should insert the stylus in the probe body, and then it is moved. Probe is moved in this direction, and it makes contact at this place, and reading 1 is recorded. Similarly, the probe is moved to this place, and then it is made to touch the slip gauge at this place, and reading R2 is taken. Now the difference between these uh, readings, R2 minus R1, okay, R2 minus R1 minus the tip diameter, should be equal to this slip gauge length. If this is the case, then the CMM movement is okay. Like this, coordinate measuring machines can be calibrated using slip gauges. Now, depending upon the inspection requirement, sometimes we need to change the stylus. That is, if workpiece is very complex, we need to change the stylus to suit different measurement tasks. For example, assessing deep features that require long and complex styli, as well as using different tips like spherical tips, disc type tips, and cylindrical type tips for measurement of threads. So styli should be optimized for the application to ensure very sound measurement results. So these styli can be changed manually using a threaded connection. So whenever we change manually, recalibration is essential. Probe systems are now available with a repeatable automated means to switch styli, reducing manual intervention and eliminating the need to recalibrate. Now, in this demonstration, we can see the movement of the probe. Now it is moving in B axis plus or minus 180 degrees, plus minus 180 degree movement. Now it is A axis movement. Now we can see the calibration of probe using master ball. Before using probe, we should calibrate. Now you can see the operator is operating joystick. He is moving the stylus and he is inspecting the inclined surface on the workpiece. Stylus is contacting at 4 different places of the inclined surface. When the probe touches, we can see the red light blinks. Now after this inclination is calculated and probe is adjusted for proper orientation. And again joystick is operated and stylus is moved so that stylus touches the inner surface of the bore on the inclined surface. It is contacting the inner surface of the bore. You can see the blinking of red light. And after getting the measurement points, software will calculate the diameter and center point coordinates. Now, recently, optical probes, also known as vision probes, are developed, and by using these vision probes, CMM can be used as a microscope for measurement of electronic circuits, for measurement of micro holes, and for measuring very rubbery materials or elastic bodies. The optical probe capture, you can see here in this diagram, we have an optical probe, and this is the electronic circuit which is being inspected by the vision probe. So this probe moves on the electronic circuit and captures the image, and the captured image is analyzed and measurement readings are taken. The optical probe captured image will have various automatic edge detections performed by the dedicated software, and then various calculation processes such as calculation of dimensions like thickness, width, depth, length, etc., and geometrical deviations will be performed by general purpose measurement program. These optical probes can be mounted on an automatic probe changer. You can see we have a probe changer wherein the different kinds of touch type and scanning type probes are mounted. You can also see a vision probe is mounted in the automatic probe changer, which allows fully automatic measurement, including both contact and non-contact types of measurement. That means, depending upon the requirement, sometimes the contact type probes are selected and inspection is carried out. And whenever non-contact type measurement is required, this vision probe is selected and inspection is carried out. Dedicated software available in the computer system displays the image window when it detects a workpiece edge when a vision type probe is used for inspection. After detecting an edge, it starts various calculations like diameter, thickness, angle, etc. with the regular general purpose measurement programs. Here you can see an edge is detected. This is the hole available in the workpiece. So the dedicated software, it detects the edge like this, and then the various points or the coordinates of various points on the selected edge are obtained, and then the software will calculate what is the diameter of this hole and what are the XYZ coordinate points of this center point. So like this, software will calculate the required details, required features. Now, using the vision probes and with powerful image processing tools, it is possible to have 3D metrology. That means it can measure, the vision probe can measure in the height direction, z-axis, also by means of its autofocus function. By using this autofocus function, the height of the workpieces, height of various features can be measured, and hence three-dimensional measurement is possible. In ordinary microform measurement, it is often difficult to remove burrs and dust. For example, so we have a workpiece like this wherein there is a hole, and here some burrs are there. So in ordinary measurement, these burrs cannot be, compensation for these burrs cannot be made. Whereas if we use vision type probes, so these burrs and dust can be removed automatically. The advanced optical probe softwares can recognize these obstructions like burrs and dust and bypass them during the measurement. Now, 3D vision measuring systems are developed wherein vision probes are provided, as well as touch trigger probes are also provided in the machine. So vision probes are used for measurement of the various features, and then the touch trigger probe is provided to reach undercuts and similar features which are not accessible by the vision probe or the camera. You can see here we